start off saying that he invests $3,800. So whatever, how many investments he makes, that total investments without multiplying by any rates come up to $3,800. Part at a simple interest, 7.5, part at 6%. So if you start, I always like to put my variables right in my sentences. So if you start like this helps you set your let statements up. So now, the first one, X and Y, here's your first statement. Because together, he took $38,000 together. So whatever X and Y is, they have to add up to $38,000. Now he's going to collect his interest. Interest is principal times rate. So we're going to take whatever his principal is and multiply it by those rates. Together, that interest income will be $2,600. God bless you. Okay, come on, whatever you need to do. Did you come up? God bless. Did you come up with the two equations? Okay, now if you want to do elimination, that's fine. You're dealing with a few decimals in there. If you want to do substitution, probably better. Substitute for the X or the Y. It doesn't have to be the same way that I did it. But you do have to come up with the same numbers. If your let statements were backwards, this will still come up to be your 7.5 and your 6. Questions? That's the one you guys like? Okay.
Can you just say the number?
Yep, I can. So don't forget, there's a difference between how much you invest and how much income you earn from your investments. Okay? So when you're investing your money, if it's how much you invested, that doesn't get multiplied by its rate. If it's how much interest you earn or what you earned from your investments, then we multiply it by the rate. It's almost like the ticket sales, if you think about it. Like the children and adults tickets add up to a certain amount. If we multiply it by their price, that adds up to a total income we get. So these are the words you're looking for. Interest income is when you're multiplying it by percent. The word investment is just his simple X and Y. Okay. Interest income is when you multiply it by the interest percent. It's a simple interest equals principal times rate. You just take whatever you put in. Like say you invest $100 and you make 10%. You've just earned $10. That's all that means. So your interest income is always going to be smaller, right? It's based on your percentage. It's a simple interest formula. Let me move over here. All right. So let's look at the last one. 8. Okay. So let's just hit this. A scholarship fund earns income from 3 investments. So we've got 3 investments. I called them X, Y, and Z. Go to your left statement. X, Y, and Z at 5%, at 6%, at 10%. The annual income available for the scholarships from the 3 investments is $1,000. What does that annual income mean? What they make every year from their investment. That's the guy we have to multiply by its investment rate. Because obviously I'm not going to invest the $1,000 that way. I'm going to get this annually from my rate. Okay? So this first sentence over here, this first guy over here, where it says 0.05x, 0.06y, 0.10z equals 1,000, that's what your interest earned is. If the amount invested at 5, and this is the 5 is the X, is 5 times the amount invested at 6. 6 is my Y. Who's making more, the X or the Y? if the 5% is 5 times more, good. So this is the equals 5 times y. There's your statement. Just put your variables right in your words. That's your second statement. When the total invested at 5 and 6 is equal to, and we need our percents with this, is equal to the amount invested at 10. So my 0.05x plus my 0.06y is equal to my 0.10z. Oh, sorry, the amount invested. Sorry, my mistake. The total amount invested. So just your x and your y is equal to your z. That means z is going to get the most money invested. When you come out with this, if z isn't your highest, something went wrong. So the total amount invested is equal to this. And just pull them right out of these words. So now we have our three variables shown here. Let me just move this down. I couldn't fit the whole thing. Okay, so now we've got 3 equations. All right, your goal is to take those 3 equations and make one equation with one variable. Now, you might have to play around with this a little bit. You have an x equal in terms of y. So that means I can take out x and put a y in there. Now I have to eliminate z in terms of y. Okay? Can I get z with a y by itself? Not right here. I can't, right? Not right here. However, I need to get a z equal with just a y something. So I can plug the y in and eliminate the z. But the only way I can do that is to substitute this guy in. I can take that x out and put in my 5y. That might be what you missed. So now, can I solve for z in terms of y? And then I can remove that z. You need to determine which variable you're going to end up with. Because I took this x out and substituted in terms of y. If I decide I'm going to take this x out and put a 5y in here, and I got a y, how can I take this z out in terms of y? So I go to this equation. So z is already solved for me, x plus y, right? How can I eliminate that x to just be in terms of y? Well, I have another statement that says, well, you can eliminate that x in terms of y. This x is equal to 5y. So I can eliminate that x. I need to solve every variable in terms of one variable. I can only work with one variable at the end.
Hang on, but I don't. You said 6y equals to 5y plus y.
No. I said x equal to 5y, and then 5y plus 1y is my z. 6y is equal to my z. I need to solve z in terms of y. I need to get z out of there and put a y in there. Yeah.
Dividing, wouldn't you divide by 0.37 because 0.25 plus 0.6 plus 0.0?
Where are you? Here? So I had to add up these first, right? And it came to 0.91. This is a 0.60. Did you add it as a 0.06?
Oh, no.
This was a 0.60 when I multiplied this. Because this was a 6y. Be careful with those decimals. A lot of people, when they start, did you learn how to just multiply by 100 and get rid of all your decimals? That's like in 7th, 8th grade. Sometimes you can multiply by 100 and get rid of these, see these 3 decimals? If you multiply everybody by 100, this becomes 5 times 5y plus 6y plus 10 times 6y. But then you just have to multiply this guy too. You have to multiply that one too. And then you're not working with the decimal. It is the same thing in the long run. But you guys have calculators, so Usually we used to do this back in the day so everybody wasn't lining up their decimal points. Everybody had to line them up. But you guys have calculators. Whichever way you decide to do that is fine for me. Find your y, round it to 2 decimal places. There's your money. Back substitute. The next one I can go back into here is my x value. And then my x and my y, I can add up to get my z. That one was a little bit. For those of you guys that need a refresher, or just to recall this is good. We are going to take this and separate this into the two pieces that it was used to combine this into. That's what's called the decomposition. Decompose them. Break them back down. So what we're going to be doing is following these steps. Did I put this on your notes? Okay. So we're going to factor your denominator. We're going to write it as a sum using A and B. Two terms, A, B. We're going to set the factors equal to 0. We're going to substitute in for A and B. And we're going to then rewrite the equation. Don't forget to rewrite the equation at the end. Okay, so let's follow it step by step. Factor this denominator. What does this give me? Good. Okay. So we're going to start like this. We're going to rewrite this in terms of the two sums. So all we're going to do is say this. I hope I have enough room here. Oops. Does it matter which one we do the x minus 3? No. Okay. Now, A, B is just, those are our two variables right now. We need to find out, what did this thing originally come out? It was a sum of something. So we're breaking this back down. So we're just going to call this A and B right now. We're just labeling A and B. Does it matter which factor I put under where? It'll work out in the end. So now we're going to multiply both sides by your common denominator. We're just going to get rid of your fraction. So that's our common denominator, the x minus 3, x plus 2, right? So we're going to multiply everybody by an x minus 3, x plus 2. I'm just going to write it on top of it here so we can see how we eliminate something. Once you see the pattern, it's going to be so much simpler. I'm multiplying by the common denominator to get rid of the fraction. So if you had this, what would you multiply by to get rid of your denominator? 10. So you're going to multiply everybody by 10, which is like 5 times 2, right? So you're going to multiply everybody by 5 times 2. You're just eliminating your denominator. So doesn't this all eliminate? And comes out to x plus 7. Which factor eliminates over here? And you're left with a times x plus 2. Which factor eliminates over here? And you're left with b times x minus 3. See a little pattern here? We didn't do this.
No, we did. Yeah, we did.
Miss Imperiali did it?
We didn't do it with the A and C.
Would you do x and y?
Yeah, no, we just like used it. Yeah, it was just canceling out, but there was no A and B.
We didn't split the two, like when you got to x plus 7 over x minus 3,
Yeah,
x plus 2, we didn't separate it at all. We just multiplied it.
Okay. So you basically didn't go back and find the equation that it came from?
Yeah.
Okay.
Because we were just reducing fractions.
Reducing. That's what you were doing. You were just reducing. Okay. All right. So we're following this so far? At least you had a little bit of comfort with fraction in there, with factoring and with fractions. Okay, so now we're going to do this. We have two factors. We have an x plus 2. We have an x minus 3. We're going to set them equal to 0 and solve. X is negative 2. X is 3. This is the most important part. Just keep following this little routine. So I'm going to substitute in an x for a negative 2. And I'm going to rewrite this. Oops. This guy is x also. Oops. Let me move this out of here. This is fun. Okay, this becomes 5. What happens here to the a term? Cancels out because this becomes 0. So anything times 0 cancels out. And this becomes what? Oops, sorry, I didn't put the negative 2 in here either. This becomes negative 5 times b. Can we solve for b? I think I'm at too much of a slant. I can't see my work. So b is negative 1. We need to find an a and a b. So we solved for 1, plugged it in, found what b is equal to. Agree with you? Okay, now we're just going to do the same thing again, and we're going to plug in a 3. And if we plug in a 3, what variable should we eliminate this time? The b. And we'll solve for a. And we're done. Okay, so now we're going to do this guy. So we're going to start it again. X plus 7. Yeah. Thank you. I can't work on a slant for some reason today. I need to be spacing it. Okay, so now we're going to plug in a 3 for this guy. And you said we're going to eliminate the b. There's my 0. Agree? Okay, so we got 10 is equal to, we get a times 5, so 5a. This kind of works out nicely. And a is equal to 2. So we've got a b and an a. And all we have to do is number 4. Go back and rewrite your equation. So we're going to rewrite it to say x plus 7, that's a 7, over x squared minus x minus 6. This is our original one. We're going to take our a, because a we put over the first guy. A is 2. And b is a negative 1. So because b is a negative 1, if I say plus a negative, I get a subtract. Agree? So this is where this came from. So if we started with this guy and we combined it into 1, we would get x plus 7 over x squared minus x minus 6. Not bad. So let's just check this and make sure this is true. I would find a common denominator. You don't have to do this, but I just want to show you that this is true. We would say this guy needs an x plus 2 times 2 minus, I'm just going to put the 1 here for now. This guy has an x plus 2. It needs an x minus 3. I'm going to collect my terms up here. 4x plus 4 plus this negative sign minus x plus 3 all over this guy again. I've got a 4x minus 1x. I get a 3x plus 7. Oops. I got a 3x. So what did I do wrong? 2x. Oh, this is a 2x. Sorry, you didn't catch me, guys. This is a 2x. 2x minus x gives me an x. I missed this one right here. This is a 2x, so x minus 2x minus x gives me an x. So x plus 7 over, and it comes out, if you want to just do that guy, FOIL that back out, it comes out to that. So we're taking, God bless you, we're taking this fraction, we're decomposing it to what 2 fractions did this add up to. That's all we're doing. I just showed you that it worked kind of sloppily because I multiplied this and got 4 instead of 2. I can't talk and write at the same time. So we're going to take these, we're going to factor, we're just going to follow this. Follow these steps right in front of you. Yeah. This is the actual answer. This is the answer. We have to go back and put those parts in to show what it equals to. I just checked it so that you would see that it does come out to be that. You do not have to do this check. Right? Not so bad. It's fractions, but they're not that scary. All right, let me make sure I told you everything. All right, so let's try another one. All right, so the first thing we're going to do is we're going to factor the denominator. What are my factors? X minus 3, x plus 1. Okay? All right, now what? Do the A and the B thing. A, and again, it doesn't matter which one comes out here, it'll work itself out. Okay. Now, we're going to multiply through the common denominator and eliminate all our denominators. So I'm going to put the factors again. Do you have to do this? No. As soon as you see the pattern, you'll be a little bit more comfortable with this. If you struggle with this, put it on top of every term and watch it cancel out. Your goal is to eliminate a fraction and just have one equation after you get this to this step. So this denominator comes out totally, agree? Have a little more room this time to write. Out comes the x minus 3, so I'm left with a times x plus 1, plus, out comes the x plus 1, I'm left with b times the x minus 3. Good? All right, I'm going to take both of those factors over to the side somewhere, set both of these factors to 0. So you're going to do this substitution twice. You're going to, God bless you. You're going to do a substitution of x is 3. It's going to eliminate one variable and solve for the other. Then you're going to do a substitution of x is negative 1. It will eliminate the other one and solve for the respective one. Don't forget to put it in this side as well. And kind of, if you didn't put it there, as soon as you went to go see what it's equal to, you would see, I got to put my x in here. So it's not a major hit. So let's use x is equal to 3. We can see this time we're eliminating which one? B. Anything times 0, got rid of. So 15 minus 3 is 12 is equal to 4a. We're going to divide by a 4. And a is equal to 3. So let's keep track of this. We need an a equal, we need a b equal. Okay, okay with that so far? All right, now we're going to do it for the other one. X is equal to negative 1. Redo the whole thing. 5 times negative 1 minus 3 is 1 plus 1. Negative 1. This is a negative. I just can't get the negative to show. Okay, so 5 minus 1, this gives me negative 5. What does this give me? Negative 8. Which one eliminates here? A. That's the 0. And what does b become? That's a negative 1. Good. So I'm going to divide by a negative 4. And b is equal to 2. That part's good. All I need to do is rewrite this. So your answer, your final answer, this is my final answer. I just want to show the decomposition. So I'm going to rewrite the original side. I'm going to put a over the x minus 3. This is where you have to put the right one over each one. And everything's positive, so I'm going to keep the positive. 2 over x plus 1. Good? Not bad, right? Not so scary.
It's such a good transition for a tray.
Oh, good. So you learned a little bit of that in trig. Enough to...
No, I mean, like, I hated trig, and this is so much better.
I meant algebra 2. And you learned a little bit before. I know you guys hated trig. I know. Hopefully the next time you see trig, it won't be as scary. And maybe hopefully you won't see it anymore, right? Any questions on this? All right. So get the next one started. And tell me what your fraction is going to look like. Okay. Chris, what did you separate this into? A over what? Okay. So we multiply out. We get rid of this guy. And so we get A times x plus 1 plus B times x minus 1. We get that? All right. What is A and B that we're plugging in? When it's 1 and negative 1? Okay, so for A and B, we're going to plug in x minus 1 is equal to 0 and x plus 1 is equal to 0. So we're going to plug these guys in. I was going to ask you if those were. I'll plug them in. So what's A equal to? 1/2. That's fine. That's fine. And then we'll do the other guy. And this is going to come out, and what's B equal to? Negative 1/2. Okay? Now, we plug these back in. We have to start like this. So I'll just put the minus in here if that's okay with you guys. Are we done? No. We can't leave a fraction within a fraction. So you just take this part and you say keep, change, so this is over 1, flip. So this, all this does is move this guy down here. So it's 1 over 2 x minus 1. Yeah, because you can't leave the 1/2 in there. And 1 over 2 x plus 1 equals this guy.
Can you, like, distribute that, make it 2x plus 2?
Yeah, you can if you want to. But it's probably easier just to leave your factors in there so that if you do go back and check it, it's easier to take the factors. So this is what your final answer will be. This one doesn't look good. Okay? Simple enough?